So, good evening, all. This is week one fabrication technique for MEMS based sensor clinical perspective. This is the problem solving session. I'm Arpita Biswas, a PhD scholar from electrical engineering department from IIT Jodhpur. So, this is about me. So, we are going to start the session. So, we are waiting for 2 3 students, then we will start the session. So this is the week one, question number one. So evaluate whether the below statement is true or false. Interdigited electrode structure can be used as a micro heater. So it is true or false. So please try to give the answer. And I hope all of you have gone through the lecture video. So please try to solve the question. So the question number one is evaluate whether the below statement is true or false. Interdigited electrode structure cannot be used as a micro heater. So I'm waiting for the response. Try to give the answer. So the statement is true. So interdigited electrode cannot be used as a micro heater. Can anyone explain why? Because if you have gone through the lecture, you can see that the micro heater structure, what happened in micro heater structure, there is a continuous Like if there is a two terminal, so there is a continuous path in between this two terminal. But what happened in for the integrated, so we are going towards the next question. This is the question number two. So prior to the gold deposition on oxide layer, a thin layer of chromium is deposited. What is the role of the chromium here? So the first option is it gives the better selectivity in etching. The second option is it helps in information of excellent electrical contact. And the third option is it releases the stress between oxide layer and gold. And the fourth option is it gives the better anisotropy in wettage. So please try to give the answer. So what is the right answer? Question number two is prior to gold deposition on oxide layer, a thin layer of chromium is deposited. So what is the role of chromium here? So when you are going for the contact deposition, like the chrome gold, then what happened? We are deposited this some nanometer, like 20 to 25 nanometer of the chromium. Then after that, we deposited the gold layer, right? Like 180 or 200 and maximum 250 nanometer we can deposit. So now the question is, what is the role of this chromium? So please try to solve this question. What is the answer? So the first option is it gives in a second option is it helps information David, this is the question number two. So prior to gold deposition on oxide layer, a thin layer of chromium is deposited. So what is the role of chromium here? The first option is it gives the better selectivity in etching. It helps. Second option is it helps information of excellent electrical contact. The third option is it reduces the stress between oxide layer and gold. And the fourth option is it gives the better anisotropy in weightage. So what is the right answer? Please unmute yourself and try to give the answer. Hello, am I audible? Hello, hello, please unmute yourself. Okay, so please try to give the answer. You can unmute yourself and you can directly talk now. Okay, so what is the right answer? Okay, actually screen is not shared. I think now, now you can see the slide, right? So please try to solve the question. So what is the right answer? This is the question answer session. You can solve your doubt. Actually, this is the first week problem solving session. I'm not able to hear you. Uh, am I audible? Hello. Can you please write here if you are not able to switch on? Okay, okay. So we can write now. You can write the answer here. So what is the right answer? Take your time, but at least try. Option two. Can you explain little bit why option two? You can write. Please explain little bit why the right option is option two. What is the purpose of depositing the chromium when we are going to actually we want a gold contact, right? So we little bit 25 nanometer, we little bit deposit the chromium. Why? Try. At least try, then I will explain. Am I audible? Hello? Gold, then we little bit like 20 to 25 nanometer we deposit the chromium because we are actually what we want a adhesive layer of the gold, right? So to for the better adhesion of the gold, we deposit the chromium. So now you can explain what is the right answer. Actually, this is all about the addition. Okay, if on the oxide we directly deposit the gold, so the little bit not that not good or like little bit it is not good for the it is gold does not have the addition, right? So, what is the right answer? Option 3. It releases stress between oxide layer and gold. So, it releases the stress between the oxide layer and gold. So, that's why the thin layer of chromium is deposited. So, what is the right answer? The right answer is option 3. Right? It is clear? Hello. Now we can move towards the next question. Am I audible? Okay. Good. So this is the question number 3. As per the breath analysis research, it is known that human breath consists of thousands of VOCs. So what is the correct full form of this VOC? The first option is vapor organic compound. The second option is volatile organic compound. The third option is volatile organic complex. And the fourth option is vapor organic complex. So what is the right answer? I think this is the easy question, right? If you have gone through the lecture, then you can solve the answer. So please try to find out the right answer. The question is, as per the breath analysis research, it is known that human breath consists of thousands of VOCs. So what is the correct full form of the VOC? David, please try to give, yes, volatile organic compound. Good. So the right option is option 2, volatile organic compound. So next we are moving toward the question number 4. An interdigited electrode can only be used to measure the DC resistance of the material placed on it. So the statement is true or false. An interdigited electrode can only be used to measure the DC resistance of the material placed on it. Is this statement true or false? So what is the answer, David? And there is no hurry, you can take your time, but at least try. Do you know about the what is the interdigited electrode? Like there is a finger type of electrode is present in between, like this type of structure is there, and this is the I'm showing you. This is the pin. So this is the interdigited electrode. You can see here. This is the interdigited electrode. This is the electrode finger, and in between this is the another electrode finger, and this is the electrode, right? So this type of structure, yeah, pad. Okay. So What is the question here? And so this is called the interdigited. Like this, there is a finger type of structure, and this is the electrode pad. So an interdigited electrode can only be used to measure the DC resistance of the material placed on it. So if there is a there is a something layer is present, active layer, and on the active layer here the interdigited electrode is present. Okay. So now the question is, it is used for only measure the DC resistance. So it is only used to measure the DC resistance in between this material or something else. So what is the right answer here? Take your time, but at least try. It is true. The statement is true or false. The what you have given, it is false, ma'am. Capacitance is also measured. Yes, good. So the answer is this is the false statement. Okay. So the right answer is false. So next we are moving toward the question number 5. So ideally the base resistance of an interdigited electrode structure should be, the first option is 0 ohm, the second option is in hundreds of ohm, the third option is in tens of kilo ohm, and the fourth option is infinite. So what is the right answer? Take your time and then try to give the answer. Ideally, right? If you have to, ideally, okay. The base resistance of an interdigited electrode. Interdigited is a structure. I have already shown that this is the interdigited structure, and here can some more electrode finger in between this, right? There is a electrode pad is present. So the question is, ideally the base resistance of an interdigited electrode structure would be, so first option, what is the right answer here? First option is 0 ohm, second option is in thousand of ohm, third option is in tens of kilo ohm, and fourth option is infinite. The resistance of an interdigited electrode structure. So this is the simple question. Let's try to find out the answer. Infinite. Good. So the right answer is infinite. So this is the question number 6. Consider the following two statements. First statement is MEMS system does not require microfabrication. And the second statement is the MEMS system involves only sensor and actuator. So which among the following option is correct for provided statement? So the first option is both statement 1 and 2 are correct. And the second option is the statement 1 is correct, but the statement 2 is incorrect. And the third option is statement 1 is incorrect, but the statement 2 is correct. And the last option is the both is statement 1 and statement 2 are incorrect. So please try to find out the answer. At first, carefully see the statement. Statement 1 is MEMS system does not require microfabrication. And the statement 2 is MEMS system involve only sensor and actuator. So now please try to find out the answer. Please try to find out. One is incorrect, but is correct. Can you explain a little bit? Just a minute, I'm sharing it again. Can you please explain? You have given the answer that statement one is like what is that? What is your answer? Statement one is incorrect, but statement two is correct. Can you please little bit explain? See carefully. MEMS system does not require microfabrication. Okay, this statement is incorrect. Okay, so MEMS system, of course, it's MEMS system. It's required the microfabrication. But what about the statement two? MEMS system involves only sensor and actuator. So think carefully. MEMS system only involves in the sensor and actuator. Take your time. There is no hurry. You take your time, but at least try to give the right answer with the proper explanation. Please try to give the answer. Main system consists of sensor for converting the physical signal into the electrical signal and actuator to convert the electrical signal into physical signal. No, David, actually you have to cross verify, okay? I'm not going to tell your explanation is right, but you are giving the answer about the same what is sensor and what about the actuator. So you can cross verify or you can go through the lecture or you can search it the Google. Okay. So MEMS system not only involve the sensor and actuator. You can different in different system like in fabrication. Now you can use the MEMS technique microsystem micro electromechanical system you can also use there not only about the sensor and actuator your explanation is right well, you are giving the what is sensor and what is actuator but it is not only used yes definitely it is used for the sensor and actuator also the in other also the mem system is used okay so this both are incorrect okay so option D is the right answer you can cross verify it. Okay, so we are going moving toward the next question. So this is the question number 7. So in the lecture, you have seen a sensor to measure the weight of a housefly. So the image showed a housefly sitting on the sensor and pads to measure the resistance corresponding to the weight of the housefly. So what was the characterization technique used to capture this image of the housefly on the sensor? So first option is the atomic force microscope. And the second option is the optical profilometer. And the third option is the scanning electron microscope. And the fourth option is the transition electron microscope. So take your time and try to give the answer. Uh, what is the right answer here? So what is the right answer? So, what is the question here? In the lecture, you have seen a sensor to measure the weight of a housefly, and the image showed a housefly sitting on the sensor. So, if you have gone through the lecture, I think you can definitely give the answer. Sitting on the sensor and pads to measure the resistance corresponding to the weight of the housefly. So, what was the characterization technique used to capture this image of the housefly on the sensor? So, first option is atomic force microscope. Second option is the optical profilometer, and third option is scanning electron microscope. And the fourth option is the transmission electron microscope. See, these are all of these are used for the capturing the microscopic the nanometer or micrometer image, right? So if you have gone through the lecture, you can give the answer. Which type of there is a picture that there is a housefly on this sensor, right, to measure the housefly weight. So what technique they have used in their picture to capture the picture? And there is no hurry, you take your time, but at least try. So the question is, I'm repeating the question. In the lecture, you have seen a sensor to measure the weight of a housefly. The image showed a housefly sitting on the sensor and pads to measure the resistance corresponding to the weight of the housefly. Okay, so what was the characterization technique used to capture this image of the housefly on the sensor? So what is the technique they have used? The first option is the atomic force microscope. Second option is the optical profilometer, and third option is the scanning electron microscope. And the fourth option is the transmission electron microscope. No, atomic force microscope is not the right answer. Please try to give the correct answer. One day I will discuss which type of if atomic force microscope type of characterization have done, then which type of structure you can see. Okay, in the next class or any after I can in the next class I can show. There is no hurry, you take your time, but at least try. And this is the basic introductory session. David, you can tell something about you. Where are you? Are you a student or something? Actually, this is the first class, so this is the basic introductory session. You can give your introduction, right? And also in the at first, you can unmute your mic and you can say there. So the right option is the scanning electron microscope. Okay, same image they have used. That they are used the same characterization technique. The housefly on the sensor, micro sensor. So they have used the technique scanning electron microscope. And the next class I will show how the optical image, like the right option is scan electron microscope. Okay, so you are a MA student, Medical Electronics 6, Anna University, Chennai. Okay, okay. Okay. So now this question number 7, the right option is the scanning electron microscope. So we are moving towards the next question. This is the question number 8. Commercially available silicon wafer are most circular in shape. Is this a statement true or false? So have you seen the silicon wafer which is commercially available in the market? So what is the shape of this silicon wafer? Okay, so what is the shape of the silicon wafer? Okay, yes, it is true. So the commercially available, yes, the right option is true. The commercially available silicon wafer are mostly circular in shape. Okay, so we are moving toward the next question. This is the question number 9. What is the material used for micro heater? So you have seen there how the micro heater structure, like if they have used like this type of heater structure, like there's a continuous structure, like this type of structure. This is a like one type of structure, the micro heater. So what is the role of this micro heater? Like in some, we are discussing later what is the role of the micro heater. Heater you can see from this word, it is using for the heater, like it will work as a heater. And micro heater, it means the dimension. Okay, the dimension, like this dimension is in the micrometer level. Okay, micrometer level, and this is used for the heating purpose. Okay, and the difference between like 100 micrometer or something. So, what is the material used for the microheater? At first, we have gone through a question that if we are deposit like contact, where we are taking the output, or we are giving some voltage something. So this is called the contact. This contact like ID pattern interdigited electrode, what we used, here we have discussed about the gold contact. And for increase the adhesion of this gold, we are using some little amount like the thin layer of a chromium, like 25 nanometer, up to 25 nanometer we can use the chromium. And we can deposit the gold like 180 to 200 or 250 nanometer, right? So here we are discussing about the micro heater. Micro means it will the range, it will vary from the micrometer range, and it will act as a heater. Okay, so now the question is, what is the material used for the micro heater? So first option is the chrome gold. Second option is the silver. Third option is the tungsten, and the fourth option is the nichrome. So please go through the question carefully, take your time, and then try to give the answer. Because this is a good question. There were here also you can distinguish between the difference between this micro heater and the contact, right? So it's nichrome's alloy of chromium K and iron. Yes. So the right option is the last one, nichrome. Good. So next we are moving toward the question number 10. Microfluidic devices were shown in the lecture of this week. PDMS is often a material that is used to create a membrane with channels, and it is bonded one to a substrate like glass or silicon. So why there is bonding is required. So first option is to ensure the fluid only flows in the channel design. Second, both the avoid to avoid the leakage. Third option is both A and B, and the last option is the neither A nor B. So please go through the question carefully and try to give the answer. Take your time, but at least try. What is the right answer? There is no hurry, you take your time. Microfluidic devices were shown in the lecture of this week. PDMS, you have seen na, in this lecture, they have used the PDMS so for molding purpose something. And this PDMS is often a material that is used to create a membrane with channel, and it is bonded onto a substrate like glass or silicon. Why this bonding is required? First option is to ensure that fluid only flows in the channel design. The second option is to avoid the leakage. Third option is both A and B, and last option is neither A nor B. So what is the right answer? Can you little bit explain why neither A or B? So state is used for holding it in shape. No. No, the explanation is not right. Go through the question carefully. Like here is the glass or glass substrate or the wafer. and now we are like using the PDMS. Like if there is a microfluidic channel, then we use the PDMS, right? In between there is a channel. So if there is a glass slide, then there is a PDMS, and in between the channel. And so we required the bonding. If there is no bonding, then if we are flowing some like drugs, if there is a sale is present and we are flowing the drugs, what happens? It will like go outside of this channel, na? So there is bonding is required. So it will stay there, and we can flow the liquid or the drugs in between it. So now it is, I think, clear to you why the bonding is required. If there is no bonding between the PDMS and the glass slide or the wafer, then if you are flowing the in between the channel, if you are flowing the fluid, what happened? Now you can give the answer. What is the right answer? Why the bonding is required? If there is no bonding between the PDMs or the glass slide, then we can't flow the fluid in between this channel. So take your time and try to give the answer. Option B. Okay, okay, okay. Good. So the right option is option B. Sorry, sorry, sorry. So what is the right answer? Option B. No, not only the option B, like, right? Yes, to avoid the leakage and also to ensure that fluid only flow in the channel design. Like if there is a channel this is the glass slide and this is the channel. Okay, so there is a drugs flowing in between the channel. So if there is a good bonding between the glass slide and the like this structure, the PDMS. So it ensure that the fluid only flow in the channel design. So in this time also, like if there is a good bonding between the PDMS and the channel, and the substrate, then it ensure that the fluid only flow in the channel is designed, and also to avoid the leakage. So option C is the right option. Okay, so both the option are right. Option A and B. So the right option is both the option A and B. Right? Is it clear? So next we are moving towards the question number 11. So identify the type of the silicon wafer. So can you identify which type of silicon wafer? Like there is a four type of silicon wafer is present. Can you please explain? First one, like if it is a first, like this is the first, this is the second, this is the third, and this is the fourth. Now you can explain. You can explain the what is it like? There is a major card and there is a small card. So can you explain what is the role of this major card and the small card? Why they are using this type of card? Because already we have discussed in the commercially available in market which have a round shape, right? So it can be this round shape. So why there is a some bigger card and the smaller card? And how we from this cart, like this the primary or secondary cart, we can identify which type of silicon wafer is this. Okay, so please try identify the type of the silicon wafer. And the third, here is the primary cut. Okay, here is the like here is the primary cut. Here is the primary cut, and this is the secondary cut. And here only the primary cut is present, and here like primary cut, and this is the secondary cut. Take your time, there is no hurry, but try identify the type of the silicon wafer. Please try to give the answer. Please try to find out the answer. See, one is P type 100. Okay, fine. And then two, like this is one, this is two, three, then four. One, two, three, four. Okay, so this is P type 100. So now tell about the two, three, and four. And also you can, yes, this is the right answer. This is P type 10. So can you please explain how you identify and what about the two, three, and four? What is the right answer here? Okay. 2 is N type 00. 4 is P type 111. And what about the 3? What about the 3? Please try to give the answer. N3, N type 11. Yes, David. So now here you can see how to find out which type of silicon wafer, right? There is a primary cut. This is the bigger one. And if there is a smaller secondary cut and it is 180 degree, like in between this primary secondary, there is a 180, 180 degree. Then this is called N type 100. Then, okay. And if this is a primary cut and this is secondary cut. So what is the angle between it? So there is an angle between it 90 degree. Okay. So what is called? This is the P type 100, right? So this is P type 100. And this is 180 is N type 100. And now it is. If there is a primary cut and the secondary cut is here and the angle between is 45. So what it is called? It is called N type 111 plane. This is the explanation why it is called 111 or 100 N type or P type, right? It's called N type 111. And the fourth one is here you can see that there is a only one cut mark. See, there is a only one primary cut. So if there is a only one primary cut, then it is called P type 111. So now I think it is clear why it is N type 100, why it is P type 100, why it is N type 111, and why it is P type 111. Okay. So here you can see the P type, first one, the P type 100, second one is the N type 100, and the third one is the N type 111, and the fourth one is P type 111. So next we are moving toward the question number 12. So what does MEM stands for? So this is the basic question, but like what do you understand about the MEMS word? Please give write, or you can unmute yourself and you can discuss here. What do you understand about this word, the MEMS? What is it stands for this MEMS? Please try to give the answer. Micro electromechanical system. Okay, this is the actually only the full form about the MEMS. Can you give a little bit explanation? What do you understand about this word? Like anything, not only about the full form, anything extra you know about the MEMS? What is MEMS? Where it is used? Like this type of an explanation? It consists of electronic and mechanical part fabrication in micro scale. Yes, this is the right explanation. Okay, so we are moving towards the question number 30. So the change in electrical resistance of solid when subject to stress field is, the first option is the piezo resistance, the second option is the piezoelectric, the third option is the ferromagnetic, and the fourth option is the pyroelectric. So the change in electrical resistance of solid when subject to stress field is, so what is the right answer? So what is the right answer? Yes, as the resistance is measured, so it is the piezo resistive. Yes, the right option is the first one. Now we are moving towards the question number 14. MEMS devices are within the range of first one is the picometer to 1 nanometer, and second option is the nanometer to 1 micrometer, the third option is the micrometer to 1 millimeter, and the fourth option is the 1 millimeter to 1 centimeter. So what is the right answer? MEMS devices are within the range of. So please go through the question carefully. Micrometer to 1 millimeter. Yes, the right option is the third option. Good. Micrometer to 1 millimeter. So next question is the question number 15. Microelectromechanical system MEMS developed using the dash techniques. First one the fabrication, second is the microfabrication, third is the etching, and fourth option is none of the above. So try to find out the right answer. The microelectromechanical system developed using dash technique. Okay. Microfabrication. Can you little bit explain? Microelectromechanical system. This is a very easy question. Yes, your answer is right. Can you little bit explain why not about the fabrication or etching? Do you know about the etching? What is etching? Why do you use the etching? And why not about the fabrication? Yes, your answer is right, but I want some explanation why fabrication and etching option is not right. Fabrication is referred to general MFG. Okay. And what about the etching? Do you know what is etching? What we used? Have you heard about the lithography process? Have you seen the pressure sensor, piezoelectric or piezoresistive pressure sensor? Like this type of a structure. Here you can see I'm showing you. Like piezoresistive or like this type of structure is there. Okay. So this is the silicon wafer and we etch the silicon wafer. Like this type of wafer is there, right? Like and the diaphragm type, like there is a diaphragm. Here the stress, we are giving the stress, right? And the diaphragm is bent and if there is a material, so its resistance or something is changed. Okay. So we are use some chemicals we will discuss later. And here we are etching. Like here this type of a structure, but here we etch using some process. We etch and we are make this type of a structure. Okay, this is the diaphragm type of structure. And here we are giving this like stress, and this diaphragm is bent. So what happened? the material also bending, so we can if there is a like stress is giving, we are giving the stress, then the resistance or something material properties change. Okay, so this is called the etching. Like here we etch, like we are use some chemical and some portion of the wafer is etched, so this is called the etching. Like, and fabrication, actually fabric, why not the fabrication, only the micro fabrication. Here is the, in the definition you can see the micro, like this the fabrication is can also we can use for the nanometer range, but when we are discussing about the micro electromechanical system, then only the micro term will come. Okay, so in fabrication, yes, it is also the process, fabrication process, but the range is in micrometer. Okay, so the right option is option B. So next we are moving towards the question number 16. So is the statement below true or false? The first, so the statement is interdigited electrode can be used as micro heater also. So it is true or false? Interdigited electrode, I have already shown you that how the interdigited electrode is looks like. So an interdigited electrode can be used as a micro heater. It is true or false? Take your time and then try to give the right answer. I think it is false because there is a insulation in between. Yes, it is false. Okay, so the right option is false because I have already shown for the new student. You can see this is the electrode, like the electrode finger. This is the interdigited electrode. Okay, so this is called the interdigited electrode. But how the micro heater look like? There is a continuous path. Okay, here this type of structure. This type of structure. There is a continuous structure, but here in between there is material is present. And we can measure the resistance capacity something. There is a reactive layer is present. We can measure. But heater is used for the heating purpose, and it is on the like this in micrometer also range. But there is a continuous path. Okay. So interdigital electrode can be used as a micrometer statements. So next we are moving toward the question number 17. For MEMS-based breast cancer diagnosis device, cantilever-based. If you've gone through the lecture, you can see there is a cantilever-based MEMS-based cancer diagnosis device is present. Now the question is, why silicon nitride is used instead of silicon oxide? So for the cantilever, they have used silicon nitride instead of silicon oxide. So why they have used? So first option is for data insulation. The second option is as stress releasing layer. Third is for data adhesion of contact pad. Fourth option is for data conductivity. The right answer here. MEMS based breast cancer diagnosis device, cantilever based. Why silicon nitride is used instead of silicon oxide? So first option is for better insulation. Second option is a stress releasing layer. Third option is for better adhesion of contact pad. And the fourth option is for better conductivity. So just wait for a minute. You can find out the answer. I'm coming back in 1 minute. So what is the right answer? Yes, the right answer is option 2. Good. Then we are moving toward the question number 18. We have discussed in the lecture about the rapid drug screening device. Answer the question in relation to the device. The design used an integrated heater. Why was used? So please go through the question and then try to give the answer. Actually, they are asking about why they are use the integrated heater. Like what is the role of the heater? We have discussed in the lecture about the rapid drug screening device. Okay, drug screening device. So no, the design used an integrated heat. Why was this used? What is the right answer? We have discussed in the lecture about the rapid drug screening and so the question relation to the device. So the right answer is to maintain the 37. David, you're right. It was used to maintain the temperature for sensing, but for here for the tissue or cell culture they are using now, so it maintained 37-degree temperature. So now try to give the answer. What are the different types of fabrication process used in MEMS? Have you heard about the surface micromachining, like Liga and the bulk micromachining? Actually, Liga is in Liga also they have used the photolithography. Photolithography is a technique they have used in Liga. Okay, so the another type of like fabrication technique they have used, yes, the surface micromachining, bulk micromachining, and
After deposition of oxide or nitride. So at first, when the silicon wafer, you have to deposit the oxide layer, and then you have to go for the the pan, the contact pad where depositing the chrome gold or something. Okay, so why there is a required of the oxide layer? Why we can't deposit the gold layer directly on the silicon wafer? So here the first option is the because direct deposition of metal on silicon gives very poor strength and adhesion for the pattern. The second option is since the silicon is a semiconductor, the conductivity effect from the bulk will contribute to the conductivity of the metal pattern layer. The third option is because of the constraint from the downstream process such as photolithography. And the third option is none of the above. So this is the last question. Please try to give the answer. Option 2. So option T, yes. So the right answer is option 2. Since silicon is a semiconductor, the conductivity effect from bulk will contribute to the conductivity of the metal pattern layer. Okay. So we are today we are stopping here. So you can leave. So we will meet again next Tuesday, 7 to 9 p.m. Okay. So today after this. Thank you. Okay, okay. Thank okay, no problem. Okay, okay, you can leave now.